Hey guys, welcome back to the lab. I hope you're doing well. Today, we are talking about molecular geometry. This is a very important topic in chemistry because, in order to understand how chemicals and chemical compounds work, you need to understand their structure. And as you will see later, these structures will look different from the way we've been drawing them so far because we've been drawing them as 2D dimensional shapes on the board or in the notebook, but these are 3D structures and they occupy these intricate structures that are very distinct and depending on what type of atoms are bound together, what types of bonds that they have, how many things that are connected to the central atom. So that's what we're going to be doing today. You will learn how to do this on your notebook, but you will also have a kit so that you can attach these molecules together, right? So by the end of this lab, you should understand very well how to build a structure of any chemical compound. You should also understand why this matters and where we use these different types of structures. So let me give you a quick example. So I have let's do like CH4, right? CH4 is carbon and hydrogen, right? Carbon and four hydrogens. Right? And so far the way you draw this, see if this is going to work. The way you do a structure of CH4, which is methane, right, is going to be some like carbon in the middle, and then it's bound to four hydrogens, right? This is the Lewis structure, which is very useful, right? CH4, that's nice. Carbon bound to hydrogens. But as we know, this is not the whole story, right? If you look to the right, you'll see that we have CH4. This is how CH4 looks like. Very different from the one that I drew. Why? Because this is a 3D structure, and this is actually the real structure of CH4. This is what we call a tetrahedral. And what's going to happen is there's nothing that's telling all the hydrogens to be flat here. They're going to kind of push each other in order to be very stable, right? In order to be very stable. This is called a tetrahedron, right? Another quick example to give you like something different, right? Let's remove this. Let's say you have NH3. NH3 is different, right? Why? Because look at this. NH3 is N bound to hydrogen, but if you remember your Lewis structures, you will know that this type of NH3 has how many electrons? It has 5 electrons, 5 valence electrons. What does that tell us? Yeah, it tells us that um, if you draw the Lewis structure of NH3, you'll see that. Here we go. There you go. All right. So you're going to have nitrogen here. You're going to have it bound to hydrogen, right? But you know that since nitrogen has 5 electrons, you'll have a pair of electrons here. And guess what? This is very, very important because this pair of electron is also going to occupy a shape. It's going to occupy a certain shape. And that will actually make it so that it pushes these hydrogen down. It's going to push the hydrogens down. So that is why the shape is going to be a little bit like that, right? It's a pyramid. We call this trigonopyramidal. Why? Because the electrons are going to also occupy a certain shape. It's very important. It's a very important concept. In fact, one of the things that you will have to learn by the end of this class is definitely the difference, to know the difference between the molecular geometry and the electron geometry, right? Meaning that the electrons will have a certain geometry and then the molecule will have a certain geometry. And I will go over it just in a bit. However, I just want to emphasize that you should watch this video and do this lab after you've learned this in the lecture. So this is just a very quick review before we get started with what you're going to be doing in the lab, right? So let's look at the review. So we are going to be looking at molecular geometry and hybridization. Again, this is the PowerPoint from our lecture, and you should have access to it. You should be able to understand it. And if you don't understand it, you should be able to review it. So if there's anything that you don't understand that I'm going to go through, take time, go back, understand it, because that's what this whole lab is about, right? So we're going to use molecular geometry and using VESPR. What is VESPR? Is the valence shell electron pair repulsion. So this is the theory that I was talking about, in that the atoms are going to try to push away from each other to occupy the most stable structure, right? So I'm going to go through a few examples of geometry so that you understand it. So if you have something called like AB2, meaning that if you have a central atom A bound to two things B, right? Then they are going to occupy a straight line. We call this linear, right? So it looks like this, right? So let's say you have barium, you have chlorine on either side. If you have something in the middle with no pairs of electrons, and then you have two things on the side, it's called linear, right? That's the first one. Well, the second one is, what if you have something in the middle, one thing in the middle, atom A in the middle, and you have three things on the side? This is called trigonal planar. Trigonal is like a triangle, right? So this is no pairs of electrons, right? So you have something like this. It's a planar because it's on one plane, and then it's trigonal because it has three, right? So this is an example. What if you have four things, right? You have a central atom, and then you have four things on the side. This is the one that I showed you. It's called a tetrahedral, like CH4, right? So this is an example, tetrahedral. Or what if you have five? If you have five things, we call this trigonal bipyramidal, right? Trigonal bipyramidal. So if you have, let me show you. Yeah, this is the example. Trigonal because it's a triangle. It's a triangle, right? Look, it's a triangle here, and then guess what? On top of this triangle, you have a pyramid on top, and then a pyramid at the bottom. That's why we call it trigonal bipyramidal. This is something in the middle, right? There's something in the middle bound to five things. So like phosphorus pentachloride. Let me go back to my program here in mole view and look at phosphorus pentachloride. So you have phosphorus and find bunch of chlorine, five of them, right? So if you see phosphorus pentachloride, look at how it looks like, right? Look at how it looks like. It's a triangle with a pyramid on top and a pyramid on the at the bottom. Trigonal bipyramidal, right? So if you have something in the middle bound to five things, it's trigonal bipyramidal, right? So that is our trigonobipyramidal. All right. So then you have one thing in the middle bound to six things, right? We call this an octahedral. That's the one that I showed you guys with phosphorus, right? One thing bound to six things, octahedral. Now, pay attention to these. These are all really fun geometries, but if you pay attention to these, you realize that these are bound to a central atom. So you have a central atom bound to a bunch of atoms in the around it. These are not, they do not have electrons on the side, like pairs of electrons, right? Pairs of electrons. They don't have pairs of electrons. If you have a pair of electrons, right? For example, you have an atom in the middle, right? You have an atom in the middle. You have two atoms on the side. Remember that earlier, an atom in the middle and two atoms in the side is linear. But if it has a pair of electron in the middle here, it's going to be bent. Why? Because, well, the pair of electron is going to bend the shape, right? Because the electron also occupies a shape, it occupies space, right? So we are going to be stable by pushing. So this is going to bend, right? So this is bent. If you have one thing bound, right? If you have one thing bound, not one thing, but you have one pair of electrons and then you have three things bound, this is the one that we looked at, NH3, right? The pair of electron is going to push down. So I want you to see something very important here. You have the arrangement of electron pairs, right? So you have this in the middle. If you look at electrons, you have electrons here, electrons here, electrons here, electrons here. So the electron geometry is tetrahedral. If we only look at electrons, counting the lone pair, the electron geometry is going to be tetrahedral, right? However, if we're looking at the molecular geometry, we will disregard the electron pair because we're only looking at the atoms, and we'll say that it is trigonopyramidal here, right? So the electron geometry is going to be different from the molecular geometry if you have a lone pair. Going back here, same thing, right? If we saw that the electron geometry here is trigonoplanar because you have three things, but the molecular geometry is bent here. So it's very important. And you can go to trigonopyramidal as well. So if you have one thing bound to five things, it's usually trigonopyramidal like we looked at. But if one of the things is a pair of electron, we have something called a seesaw, right? The electron geometry is still trigonopyramidal, but the molecular geometry is a seesaw. And why is it a seesaw? Because it's like a seesaw, right? See how like it's a seesaw. This is a seesaw that can swing back and forth. So it's the same thing. So it's very important to know the difference between molecular geometry and electron geometry. So this website right here is the one that I have been looking at. I have been using to visualize some of these. So I really want you to understand this. And on top of this, I want you to understand the polarity. So we did talk about the polarity as well. And as well as hybridization. So I will not talk about all of this because I talked about it in the lecture. You should have a PowerPoint and a video for this. But for this lab, let me see if I can look at the lab here. Yeah, for this lab, I will give you a table like this. Right? I will give you a table like this, and then you will first give me a Lewis dot structure. You should be able to know how to draw this electronic shape. That's the electronic geometry that we just looked at, and the molecular shape is the molecular geometry. It's very different. Can be different. Sometimes they are the same, but it can be different from molecular shape. And then I want you to look at bond angles, right? Bond angles. So if you go back to here for each one of the geometries, we do talk about their bond angles, right? We do talk about their bond angles, and depending on what geometry you have, you're going to have a distinct bond angle for each one of these, right? You're going to have different distinct bond angles that I want you to put into that table, right? We also have hybridization. So each molecule or each geometry is going to have a different type of hybridization. Again, you should already know what hybridization is. If not, then I'll be happy to explain more. But I have in your PowerPoint, I have different geometries and different types of hybridization and how hybridization forms and all that stuff. I even have like kind of a good table summary for hybridization. So make sure that you understand that. Make sure that you understand that so that you can put it into that table, right? We also have whether or not something has a polar or non-polar, and then you're going to be able to give me the formal charge as well. All right. So I think with all that background, you should be ready to get started on the lab. But if you have any questions, be sure to let me know. Okay. All right. Let's get started. For this lab, you are really not going to be performing experiments, but you will start by filling out the table that you've been given, and I want you to work on the geometry, the polarity, and everything else that we've discussed. So make sure that you take time to fill it out before you start with the geometry. But after you fill out your tables, after you make sure that you understand all of the material, because it's in the background as well, and I think I explained it really well. After you do that, go ahead and get your box. So you should have a kit box that we have given you, right? And the box should contain some models. So this is for you to move around, play, so that you are able to understand the geometry in a 3D space. So for this, you are going to take out everything, right? Make sure that you have everything, and in here you should have a bunch of molecules, right? And the molecules are color coded so that you know which one are which. Usually carbon is black, oxygen is red, but make sure that you read the instructions that came with it. Hydrogen is usually white, right? You will also get bonds, right? So you have bonds like that, right? You should have a single bonds and double bonds, right? And these will help you connect your molecules, because what we're going to do is connecting the molecules together and actually forming the molecules that you have drawn. So take time and put all of them together, right? For example, here we put together H2O, which you just connect atoms of oxygen and hydrogen, and as you can see, it shows the right geometry. All right, so go ahead and do that. Connect all of them, connect all of your atoms, and then whenever you connect it, make sure that you show it. I don't want you to take a picture or anything, but every time you connect it, show it to the camera. And I also want you to measure its angle. So you should have a protractor. This is another example of CH4, which is a tetrahedral, right? So I want you to show it to the camera like that. And after you do all of that, guys, I want you to measure the angle. So you should be able to measure the angle with a protractor to see if it kind of matches with the angle that I have given you, or the angle that you have calculated on your worksheet. So make sure that you do all of them, fill out the table, and that will be the lab for today. But that is the lab for today, guys. Make sure that you complete everything, the pre-lab, the data, the post-lab. And as usual, be sure to send me a message if you have any questions or need any help. Other than that, I will see you in the next lab. Bye bye.